is roots as fractions. So first of all, let's start off with our law, and then our law explained a bit. Okay, so here is what we're going to be working with. We have this very abstract form, and then how it breaks down. And
so this is the law, right? This is just basically the law.
yeah, and it's in its most abstract, pure form.
So this is one form, right?
Yeah.
And then this is the same thing, but it's just expressed with a fraction, a fractional exponent.
Correct.
All right, so what we did down here is we kind of labeled all these little parts and stuff. I always refer to this thing, I always say it's the house.
By the TV show.
But it's actually called the radical, right? And then we have this little number that would be outside the little house or outside the radical. It's called the index. And what we have here in blue, like this says denominator, this says numerator, we're talking about this thing right here, how that's going to break down in the fractional exponent.
And I forgot to write this, I just did.
Oh, so that base is called the radicand?
It's called the radicand. It's the base as in the base of our...
Oh, that's interesting. So it's underneath the house, it's called
The
the
radicand.
radicand. When it's outside the house or like this, it's called the base.
Right. Radical,
Wow.
radicand.
So as you can tell, math is a lot of vocabulary. It's a good thing to write this stuff down, or always.
And it makes it easier when communicating with somebody. You know, hey, did you see the index on that radical? Oh yeah, I forgot about that.
Yeah.
You know exactly what they're talking
It
about.
gives you the words to talk about this stuff, so you don't have to use house if you don't want to, right? You can actually say it's the what? It's the radical. All right, cool.
Okay, so let's get an example here. So let's say we're looking at the square root of 3. Now, if a number doesn't have an exponent, so I mean, if the radicand doesn't have an exponent, it's taken for granted that the exponent is 1. So let's just...
I'm gonna leave that there. I think you have some space to work.
Yeah, I do actually.
I'm gonna leave this here so that they can reference these little vocabulary words.
See that? And, okay, so in fact, in this case, our m would be 1, but again, we don't need to write the exponent if it's 1. But for sake right now, let's just put it in. And let's actually label that this is the square root. So here it would be in this form. Our a is 3, our m is 1, and our index is 2. As a fraction, it would be 3, there's our a, to the 1/2.
Use that big red marker.
Okay, that we've just converted a radical into an exponent, a base with a fractional exponent. Okay, and these, well, hold on, we'll get onto that.
Maybe you can do another example. Let's just keep it simple. Like, what does this compare to? Can you put like 2 times 3 is equal to 6, and then, or is there like an example like that that could be like, where it can show how these are inverse of each other, that they're opposite?
Oh, yes, with working with fractions, because what is a root? And the root is undoing the power. So let's actually just look at this.
Okay.
Let's look at the square root of 4. Okay, but we can break down 4 to 2 squared. So let's actually put this 2 here.
Okay.
So we can say this is 2 squared. But if we look at this now as, and this, I hope this is answering the question, or I might be getting off.
Okay.
We can write this as 2, there's a lot of 2's here, to the 2 halves, which is
1.
2 to the first, which is 2, which is a really long way of going about. The square root of 4 is 2, but this is actually checking, does this in fact all work?
I like how that kind of goes together, you know. I think there is a lot of 2's here though.
Yeah, we should try one with
So this
9,
2,
in fact.
so let's just cover these little parts based on that rule that's on this board behind my head. This 2 is this 2. This 2 is going to be the numerator, so it would be this one. These ones are the same, and this one is the denominator. as we kind of said in this thing over here. So, okay.
Let's try this with, rather than 4, let's look at 9. Because then that gets us away from, or even 25. Let's do with 25. The square root of 25. Square root of 25. Again, let's look at this as the square root of 5 squared being 25. And since we're dealing with square roots and we're dealing with perfect squares, these are always going to cancel themselves out, divide out. So this is 5 to the 2 halves, which is 5 to the first, which is just 5. And in fact, the square root of 25 is 5. Now in the last video, we got 7/6.
Mm-hmm.
It was, I'll have to go back and look at the video. Can't remember what it was.
How did we get that?
Because we were adding fractions.
That's right.
So, if we have, I don't know, what kind of root do we want to do?
Wow.
Pick a root. Pick a number.
Pick a 3.
All right.
Look at the cube root.
And let's take 7 to the 4th. Okay.
Sounds good.
If we were to write this out, okay, first of all, let's just see, can we take out anything? Well, we have 7 times 7 times 7 times 7, right? This is 7 to the 4th.
It's just an expanded way of saying this, right?
Right. And then linking this back with the last video, we see that the group of 3 can come out and the representative, we just need the 1.
Right.
This guy cannot come out, so we should get 7 cube root 7. Now in the last example, our exponent was to the 7/6. This is happening right here, but let's look at it in fraction form.
Okay.
So we have, let's put this up here, 7 to the 4th. As a fraction, this would be 7 to the 4 thirds. Now,
okay, move out of the way.
fractions are always division problems. It's always telling us to divide numerator by denominator. In this case, we have 7 to the 1 1/3. If we turn this mixed number into its, this improper fraction into its mixed number, well then this whole number is the amount of 7s that came out. We already have a representative.
Oh, it's that group of 3 that came out. We had
There's
one
whole
group
of 3.
that came out. I see.
And then this is how many were left behind. So this is 7 to the 1st, but we're still taking the cube root of a 7 that's raised to the 1st power.
Wow. That's cool. That's deep, man.
And it, well, later on in later mathematics, it's much nicer to work with fractions.
So, can we give them a couple of problems just of practicing converting one to the other and the other to the one? If that makes sense,
Yeah.
going back and forth. Just put up a problem here and let's just take a look at it. Maybe give me a shot.
All right.
Let's see if I can do it.
So let's see. Let's put. We'll go to 3 to the 5/7. We'll convert this into a radical form, and then let's take.
Okay, I'll trade places with you.
Okay.
All right. Okay, I've never done this before, so if I have, I don't remember it, so I'm going to try it now. What I'm going to do is I'm going to reference the little rule that he gave us, that Michael gave us. Okay, so I have this fractional exponent, and I want to convert it to the little house, right? I want to convert it to a root with the radical, so I'll go ahead and start with that. I know I'm going to have the radical, right? It's called the radical. I like to call it the little house, but anyway. Okay, so what am I going to do here? So I have, what do I have? I have this, and I need to put it into this form. So it looks like my A, or the base, is going to be the thing that's inside, right? Now, the numerator, this 5, in the general rule, it's the m. Seems like the 5 is going to go where the a is, right? Or it's going to be the power of the 3, right?
Correct.
And then the
Where the m
7,
is.
the 7 is over here. Did I do that right?
Yeah, and looking at it in fraction form, can we have ever pulled out any 3s? Will ever a
No.
group come out? No.
No, because this is a proper fraction, it's
Right.
less than 1.
Right.
So there's not even one whole group to come out.
Exactly.
Interesting, very, very cool. Okay, so then this one down here,
Let's leave that.
yeah, just leave it there, I need it. So I know I'm gonna be putting it into I'm gonna put this root, this 9th root in this case, but this root, I'm gonna move it into a fractional exponent, right? Okay, so let's give that a shot. So again, I think I'm gonna have the same base in both, just the same way we had it here, so I'm gonna just pull the 7 out. And then I'm gonna have a fraction over here. I like my fractions straight. I know
Oh,
you
yeah.
kinda go, but either way. Well, let's just keep consistency here.
You know what's interesting while you're racing? I only write the diagonal when I'm writing
Fractional exponents.
fractional exponents.
Yeah, I don't know what, we'll try to keep it consistent here. So there's my fraction bar. Now I just gotta figure out which one of these goes where,
Mm-hmm.
right? So the one that's outside, what's this thing called again? It's called the index, is the n, and I'm looking at this right here. The n is the denominator in the fraction, so the 9 goes here, right?
Mhm.
And the 8 is my numerator, the power of the 7 anyway. Did I get to it right?
Yeah, and then again here, before we even get to fractions, we see that not 1/7 could have left the...
Again, because the fraction is proper.
Right.
I'm gonna move it a little bit closer, just 'cause it feels like the 7 is alone. You know. Okay, there we go.
All
So
right.
I think that's pretty good. I think that's a good video on how to do this. If there's anything else you wanted to mention?
Yes. Now, going back to those... Let me switch you here. Going back to those, the last, well, at least, pardon me, an earlier video, we talked about the law of exponents. So we can take this a little bit further now. If we have, let's just say, 25 squared, okay, and this is inside of a cube root. So can I break this down? Well, there's something happening right here that we can break down even further. 25 is already 5 squared. But, so let's kind of write that here. 25, the whole 25 is being squared. But 25 is already 5 squared, but then this whole thing is being squared. That's what that square is, right? The 25, that's 25. So this is actually 5 to the 4th power, because it's 2 times 2.
Mm-hmm.
Okay, so now when I put this back in, I can say that this is 5 to the 4th power cubed, which is 5 to the 4 thirds, which is 5 to the 1 and 1/3, which is 5 cube root 5.
Yeah, so you're saying that this whole number that came out, is representing that we pulled one group of 5.
Right,
out
and I'm
here.
going to give you one of these now to work with.
Okay.
Because we had that
Because
improper
you went
fraction.
really fast.
Yeah.
You just kind of wrote everything down, said there it is.
Yeah, that
So-
wasn't very good. Sorry about that. But because I was using an earlier video,
Okay.
I should have. I went through faster here, and then this was our new stuff. So you try it.
Okay.
Again, we're tying in 2 videos now.
Right.
So let's try. Oh, this is gonna be fun.
Okay. You notice he says it's going to be fun. What does that mean, right? My students tell me the same thing. All right, let's see. Okay. So what am I supposed to do? What was the goal here? What's the?
Okay, so looking at this, and this is how I always saw it when I got these problems. Man, I can't. There, 81 can't come out. There's not 4 of them, right? It's only saying there's 3, but there's another game being played here
Yeah,
underneath.
because 81 is a perfect square.
Right,
Is that-
and it's made up of,
9 times 9.
which is also,
So I could write down this. So I have 3 81s, right? I could say that I have this. Put my little 4 here. I could say I have 81 times 81 times 81, right?
oh, I see you're going with this, I like this.
I can do that, right? I mean, that's what this says.
Right,
Or I could say, I'm gonna put my little 4. 81 is 9 times 9. So
Right.
I have, that's 81,
Mhm.
and I have 3 of these. So now I gotta,
you got 3 sets
I'm
of
gonna do it
those.
like this. I'm just gonna kind of tie them in together like that. I have 3 sets of these.
Right.
Or,
Right.
or
Because-
I can go and,
Because right here, we see that.
maybe I didn't need to go that far. But anyway, put my little 4.
No, I like what you're doing.
I could say this is 9 to the 1, 2, 3, 4, 5, 6. I could say that. So in other words, this fourth root of 81 to the 3rd can also be expressed as the fourth root of 9 to the 6th.
Correct.
Okay. Now what am I supposed to do with this?
Okay, well, finish this one out because
Well, where am I going?
turn this into
A fractional?
a fractional.
Okay, so I'm going to go ahead and go straight over this way. Okay, so my base stays the same. I'm going to put my base, and I'm trying to remember what the 6 was. I got to look at my rule here. So the exponent on the base is m. M is the numerator. Okay, so that's going to be the numerator. 6, oops, that's a terrible 6. 6 over 4. Boom. Now it's a improper fraction, this one is, right? Meaning that it could be 1 and, what would that be? 1 and 4/4?
No.
No. Dude, what the heck, man? I can't even, I forgot my fractions. It goes into it once and there's a remainder of 2/4, 1/2.
Right.
So, okay.
And there is a lot going on here. I mean, fractions are there's so much happening in them that
Yeah.
if we reduce this, because we can reduce this, even though it's a fraction and we're still dealing with roots, it still holds all the properties of a fraction. So this could be 3/2.
3/2. Yeah, okay. We have room, we have plenty of room. Let's go ahead and keep going here. So 9 and 3/2. We're just reducing the fraction to
Right.
its lowest terms. It's still improper, right?
Right?
So could I rewrite it one more time? With 1 and 1/2?
Yes.
Wait, I still need the 9. People on video going, what? So 1 and 1/2.
Right.
Okay, so this is saying that one group of 80, whoa. What is that saying?
This is saying 1 whole 9 can come out, which we saw right here.
Yes.
So 4, there's a
So
representation.
yeah, this 4 would be these 4 9s being grouped together, pulled out, and then I only need one representative of that group that was inside.
Right. The fact that there's
Leaving 2 inside, but anyway, go ahead.
So we have 9 in the first, and the fact that we have a fraction, a mixed number, states that we still have this base inside this radical.
So it's interesting when we talk about that, this is still a radical. It still is this little funny little house.
Right.
It says that, it's in there, we have to understand that that's what it says.
If we didn't have any more need of a radical,
So could I write
our
it?
mixed number would be, it wouldn't be a mixed number, we would just have an integer.
So how can I rewrite that in a radical form that's more simplified? 'Cause
So
this is obviously a radical,
So we could have,
somewhat simplified right here, but these numbers can be reduced, is what you're saying,
right, but it's, to me, I can only see it
in the fraction
in
form.
fraction form.
And I would not recommend reducing here. I would say if you're gonna reduce, make sure you're using fraction.
And there's still something happening here that
So let's
that
see.
we're gonna have to deal with.
Well, hang on. So I can write that in a root form now, right?
Yeah, so 1 whole 9 came out.
1 whole 9 came out. My Whoa, what root is this? This is a 2 root, huh?
Yeah.
Well, normally a square root wouldn't have the 2, but for the sake of instruction, we'll put the 2 there. And there's a, what does that 1 mean? Well, I'm looking at this 1 right here. What is that?
Well, that is still the fraction.
That means I still have my base. I
Right.
still have a 9 inside.
That's because you have a mixed number. If you didn't have, and we're going to see this in here in just a
And
moment.
it'd be kind of like that 1
Right.
is the 1 that goes on there, but it really isn't there.
Okay.
So the real way this would look would be like this, right? It wouldn't have the 1 exponent, and they wouldn't have the 2, is what we're saying.
And
Because the little radical sign already means automatically there's a 2 there. But
what's happening here?
wait, what do we mean? What?
Look what we have.
9 root 9?
Square root 9.
Square root 9. I'm kind of going back to the 81, I think.
Square root of 9 is 3.
Oh, you're right. Oh, so it keeps going. So then I get 9. Oh, wait, I got to pull a 3 out.
Right.
So I'm going to put it up here, okay, you guys? So I'll go ahead and leave the 9. And now I'm going to take this 9 and put it into its roots,
Right.
which is 3 times 3. Now remember this, there's a little 2 here that's imaginary, just remember that. And now I can actually pull a group of 2 out. I can pull this 3 out, right? And when they're outside, these ones get multiplied. So this eliminates,
Right.
because there's nothing left underneath the radical or the house, leaving 3 times 9 is 27? Huh. I knew that.
Now, we could discuss something happening here.
So this 27 would really be the answer then.
Correct. Here, whenever you're working with fractional exponents,
I think we'll do that other way now.
if you ever get a mixed number, it is a clear indication that you still have a radical to deal with, or maybe you can't deal with this.
When you're
this
saying a
was-
radical, you're talking about the little house,
I'm
and
sorry.
something inside the
Yeah,
house.
so
Okay.
one whole came out, or whatever the whole number is on that mixed number, that's how many come out, and that's the power. So if this was 9 to the 2 and 1/3, it would be 9 squared because 2 came out, 2 groups of those.
It'd be 81 root.
Right.
Yeah.
Now, but here's cool. We're going to back up a couple of steps. Right here to this step. Okay. Because, let me just
Yeah,
erase
just
this.
simplify some of that, yeah.
This can be, and actually, I'm going to have you do this. We'll switch again.
Okay.
Break down those 9s to 3s.
So 3's. Okay, so each 9 is 3 times 3, so that means I'm going to have for the first one, 3 times 3, 3 times 3, 3 times 3, I'm not putting my times is in. On the fourth one now, 3 times 3, fifth one, times 3 times 3, and the last one, 3 times 3.
Poor guy thinking
Okay, all right. He's like, no, remind me to. Okay.
Okay, and then let's remember
All
our
right.
fourth root.
We're on the fourth root. Now we can play our little game, right? I can play
Right.
my Jack's game. I'm gonna bounce ball.
But no.
Oh,
Write
no?
this in fraction form. Let's see what happens in fraction form.
So okay, I would write the base with how many of them are, like with an exponent.
Right.
Okay, so I get my little fourth root. Now my base is 3 because that's the one that's getting multiplied to itself a whole bunch of times. I got to count how many times. So let's see. Here's my base, and my exponent that I'm going to put here is how many of these are being multiplied together. So 1, 2, 3. I meant to do that. All right. Let's try that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This would be 3 to the 12th. Fourth root of 3 to the 12th.
Right. Now, as a fraction,
Okay, I need this board. Okay, as a fraction, again, my base, I'm going to keep it the same. That much I do know. And I'm going to have a fraction here. And this is the numerator, I believe? Yes. Yes, I'm looking over here at the...
oh,
Yeah, this exponent is the numerator, so the 12 goes up here. And the 4 goes down here.
Now,
We have that improper fraction again,
and 4 will go into 12 evenly.
3 times.
So we're left with 3 to the third,
Or 27.
or 27.
Oh man, that's out there, man. I don't even know if I can remember that. So watch the video a few times. What should I write here? Should
Let's
I
just
write?
finish it out, yeah. Because we could deal with this fraction. It's 3, 2, and then 12 minus 4. Pardon me, 12 divided by 4.
12 divided by 4 is 3.
Right, it's an even nice number. There's
So
no...
it's 3 to the third, which is equal to.
Which we saw we got 2 different ways.
Wow, that's deep. Again, I say that again. I'm like, man, my mind is blown, right? So cool. All right, man.
All right.
Anything else?
No, that's pretty good.
Bring the law back into the screen. So really, flip-flopping the whole topsy-turvy thing is really just right here. If you want the vocabulary to all these little components, here they are. These just help you at least ask a teacher, ask a tutor, and have the vocabulary so that you're talking about the right thing. Or you can say little house. That sometimes works too. All right, good luck. Keep practicing.